Should we get started, Vanessa?
Yep, let's do that. Okay, so we're getting started. Welcome to this webinar, Examining Ageing in the British Cohort Studies, Measurement, Research and Access. And we've had a great response, so thank you so much for being interested. And this is the second of, we hope, many themed webinars here at CLS. So I'm Vanessa Moulton, and I'll kick things off, and then I'll pass you over to George Probidis, and we'll finish with a Q&A at the end with us, and also Dario Marino Agostino and Laura Gimino from CLS, and the session will be chaired by Morag Henderson. So I'd like to start off with a bit of housekeeping. So to let you know, we're recording this session, so it will be available at a later date, excluding the Q&A element. If you have any questions, please use the chat function, and note that your questions will be visible to all attendees, and we'll hopefully be able to answer all of those at the end. Any technical issues, please email us at ioe.clsevents@ucl.ac.uk. And finally, your feedback is really important as we're putting together training and continually reviewing our program. So please complete the short survey at the end. It only takes a few minutes, and your views will be greatly appreciated. So today, the aims are to outline ageing measures and data available in the CLS cohorts, how to access ageing data in the CLS cohorts, highlight the types of ageing research that can be done using birth cohorts, and hopefully by the end, you'll understand how the British cohorts are a unique resource in the study of ageing. And as I mentioned at the end, you'll have the opportunity for Q&A, and we will finish at 2 o'clock. So the British cohorts have a number of advantages for conducting ageing research. So briefly, and George will expand on this, so since individuals are followed longitudinally across their lifespan from birth or even from pregnancy, birth cohorts allow us to delineate associations between early exposures and subsequent outcomes. So you can look at outcomes at different points in the life cycle, so adulthood, midlife and beyond, and use the prospective information to look at risks and exposures early in life, as well as being able to control for a large number of factors in your analysis. The data also captures major transitions, so for example, retirement, and because the data is multidisciplinary, it also captures varied aspects of people's lives, so economic, health, social, and much more. Some measures are also repeated over the life course, and as the cohort members grow up, we can make cross-generational comparisons across cohorts at different stages in the life course. So the UCL Centre for Longitudinal Studies, we manage a unique series of cohort studies, and the four cohort studies we're looking at today are the NCDS, the National Child Development Study, who were born in 1958 in Great Britain in the same week, and the initial sample for that cohort was 17,500. Next is the 1970 BCS British Cohort Study, again born in the same week in Great Britain, around 17,000 participants. Then Next Steps, which is slightly different from the other three, as the study began when they were aged 13 to 14 and was initially run by the Department for Education up to age 20, is England only and has just under 16,000 participants. And then finally, the MCS, who were born in the UK from 2000 to 2002 and had around 19,000 participants. And I'm going to focus particularly on the older ones. So before I explain this chart, some among you will have noticed another study appear there, which is the 1946 National Survey of Health and Development. And the reason that I've put it here is that I've included it as some of the cross-generational research that George will be discussing includes the 1946 cohort, this cohort, and in relation to ageing research, this is in many ways is the kind of ancestor as the NSHD, so the 46, the NCDS, the 58, and the BCS 70, the 1970, they were born 12 years apart and are in their 50s, 60s and 70s subsequently. All these studies are ongoing, and this chart shows on the horizontal, the year on the horizontal and the age on the vertical, and the dots refer to periods of data collection. So the oldest cohort we currently run at CLS is, as I said, the 1958, and since birth there have been 10 data collections, excluding the COVID surveys, which I'll talk about in a minute. And the last available collection as we speak is at age 55, but very excitingly, the age 62 to 65 sweep of data will be available by the end of the year. For the BCS 70, since 1970, 9 data collection periods, and the age 52 to 53 data will be available in the autumn. And next steps, so from 2004, inclusive data was collected every year, 7 in total, all until they were 20. And the last sweep was when they were 25, and the age 32 will be available early summer. And the MCS, including the first data collection at 9 months, have 7 sweeps, the last at age 17, and the age 22 sweep is currently in the field. And as I mentioned today, I'll particularly focus on the 70 and the 58 cohorts. So as an example, I'm going to give you a brief overview of data collection in one of our studies, the 1958 National Child Development Study. So in total, there have been 11 sweeps of the study, which are currently available, soon to be 12, as I mentioned, with the new sweep at the end of the year. In the early sweeps of the study, the main respondents were the parents, particularly the mothers. And at age 16, there was rather more involvement from the cohort member themselves, who became the main respondent from age 23 onwards. This study began as the perinatal mortality study, so the early focus was medical. In all the childhood sweeps, there were medical examinations, and other information was collected from schools, for example, how the child behaved in school and their examination results. Height and weight has been collected at most sweeps, and a biomedical sweep at age 44, including blood samples to extract DNA, and there'll be a new biomedical sweep at age 62, 65, as I mentioned, will be available very shortly. Cohort members also sat a variety of cognitive tests and mental health scales in childhood and adulthood, and a variety of linked geographical data is available, and consent has been asked for health and economic records. So the number of participants taking part in each sweep is shown at the bottom of the chart, and you can see that the number taking part has gradually dropped over time. But in midlife, we consistently collected over 9,000 we collected results from 9,000 participants, and we expect for the most latest sweep to have over 8,000 for the age 62-65 survey. So in addition to the ongoing cohort data collection, in 2020 and 2021, cohort members also completed COVID-19 surveys. There were 3 waves of data collection at different stages in the pandemic. During the autumn 2020, when restrictions have been eased in autumn 2020, and again during the 3rd lockdown. And the surveys were completed online. As well as the online surveys, participants who took part in the COVID surveys were invited to provide blood samples. 2 antibody tests were conducted, the NSA and the SSA, and the same antibody tests were conducted in multiple longitudinal studies, including ELSA and NSHD, the 1946 cohort. In particular, I just want to stress what makes the CLS COVID surveys unique from most other COVID surveys is that they are embedded in the survey and can be used with all the wealth of prospective information collected pre-pandemic to investigate outcomes during the pandemic, and very soon, excitingly, post-pandemic too. We also have genetic data currently available in the NCDS, well over 6,000 participants with genetic data. Just recently, over 5,500 have been made available for the BCS 70, and for the MCS, over 20,000 of either the cohort member, the biological mother, or the biological father. For next steps, saliva data has been collected, and there is funding in place for DNA extraction and genotyping. And more details about the genetic data can be found at CLS geneticsgithub.io. Data access, the data access system is fairly quick, so less than a month for an initial response, and the form is fairly simple, and further instructions can be found at the CLS link there. Soon to be available, excitingly, are polygenic scores for multiple health and social phenotypes, and we'll be holding a webinar later in the year on that specifically. And there's also data available for DNA methylation. So, for example, you could derive your own multiple epigenetic clock measurements, and that's something that we'll be doing in the future too, to append to the data. Also, biological samples are available for extraction if you wanted those, blood and saliva in the NCDS and blood in the BCS70, and more information on application can be found there at the link given. Also, within the Centre for Longitudinal Studies, there's a substantive ongoing record linkage programme. Consents, as I mentioned, have been collected to link health and economic data. And so far in England, hospital episode statistics, which include, for example, admitted patient care, critical care, accident and emergency care, and outpatient care, are available in all our cohorts via the UKDS secure access. In Scotland, the Scottish medical records, including inpatient, outpatient, birth and neonatal records, and prescribing information have been linked to the BCS70, NCDS and MCS via the UK Data Service secure access. We also have education, attainment and other records for the younger cohorts. For the older, the NCDS and BCS70, we have recorded deaths in Great Britain via the UKDS special licence. And coming soon will be a refresh of the hospital episode statistics in England, and next year mental health data specifically will be appended. There are user guides available on the CLS website outlining the details of each of the data sets. And if you want to hear more about using specifically the linked health administrative data in the cohorts, there are a couple of training videos on the CLS training pages and YouTube, one describing the data and another focusing on how to use the analysis, how to use and analyse the HES data. And just to say, we should also mention the UK longitudinal linking collaboration, and it's an endeavour with many of the UK's most established longitudinal studies to provide a data resource with linked health and non-health data. So just to make you aware of that. So I'm now going to focus on health, socioeconomic, family data, and talk generally about the typical kinds of data that's collected at different stages of the life course, and then go into a bit more detail on specific economic activity, physical health, cognition, and mental health data. So first, health life course data. So data collected captures the life stage, obviously, the typical events that might happen during that life stage, and also some measures are repeated to capture change over time. And here you can see that, for example, in very early life, there's information captured on pregnancy, obstetrics and birth weight, for example. And then when we move into childhood, we capture, for example, childhood illness, in adulthood, fertility, menstruation, in midlife, for example, menopause, and later diagnosis of medical conditions, medications, physical functions, etc. So, for example, we can look at early life event factors, for example, obstetrics and pregnancy, and how that might influence later life outcomes such as physical function. In your 50s and 60s, we can also use these early life factors as controls, as confounders or measures in adulthood. For example, you could use medical conditions, for example, to mediate, so explain the relationship between those two variables I mentioned. Also, as shown here, some measures such as mental health are repeated across the life course, so we can look for at examples, how poor or good mental health across the life course influences later outcomes. So a quick look at socioeconomic data. So across the life course, we know that where they live, and this information is available at different levels of granularity, and therefore we know if they've moved, where they've moved to. We also know their housing tenure, so home ownership, renting, etc. And there's a lot of information on accommodation. So across the life course, we have data on paternal and maternal occupation, income, highest education. We also know, in some cases, the grandparents' occupation, the cohort members themselves, and if applicable, their partners. And as the cohorts get older and their children get older, we ask for their work details and qualifications. So in essence, we're collecting information on 2, 3, or 4 generations of socioeconomic status within each of the cohorts. And for the cohort members themselves, where possible, we also collect educational qualifications across the life course, including ongoing and later lifelong learning in adulthood and beyond. And another example I wanted to focus on was family and relationships. So at each suite, we collect household composition, so we know who the cohort member is living with, and often their exact relationship to the cohort member. We also know their partnership histories. We collect parents' marital status, partnership formations, information about the cohort members' childcare. As they grow up, information on their family life, friends and socializing. In adulthood, the cohort members' partnership, relationships and changes, quality of their relationships. In later years, social and emotional support. And also key information on their children. So the number of children that they've got, where they're located, for example, and their relationship with their children, and also information about their parents, the cohort members' parents, so mortality, their relationship, location, frequency of contact, and the cohort members' care of grandchildren and also their parents. So I'll now focus on 4 key areas. As you've seen, there are many others. I'll give you an idea. It'll give you an idea of the breadth and depth of information available. So first, I'll focus on economic activity. So here are basically the columns and they tell you at what ages these measures have been collected. So we'll start off with occupation. So occupation of the parent in childhood, and then the cohort member as they obviously start working. And this has been measured at most sweeps, and this allows for us to code things like social class and standard occupational classification. We also have data on employment histories across the life course. We also have information on earnings from work for the parents, and also at most sweeps for the cohort member, and at some sweeps also their partners. Also income from other sources, so for example benefits and investments. We also capture wealth, especially for the older cohorts, so housing wealth, their financial wealth, and for the most recent sweep of the NCDS, pension wealth, where exact values are not captured. For example, we have data on whether they have particular assets. So for example, in earlier sweeps of the 1950 NCDS and the BCS 70, in midlife, if they have a pension, for example, and the type of pension that they've got, etc. There are also questions around their expectations for retirement. And in the older cohorts, we also capture whether they've received an inheritance, and for the latest NCDS sweep, if there have been any intergenerational transfers. So regarding physical health, there are a mixture of self-reported and objective physical measures on the cohorts. And at most sweeps within each cohort, with the exception of next steps in childhood, there's a measure of self-rated general health as well as long-term illness. Also in the NCDS, BCS 70 and MCS, medical conditions are identified, and sometimes more extensively in particular sweeps than others. Again, a range of anthropometric measures are captured at most sweeps. There are also self-reported questions relating to health behaviours such as diet, smoking, drugs and alcohol consumption and sleep. And as well as objective measures on health behaviours, for example, the accelerometer that was worn at age 46 in the BCS 70. And as I mentioned before, we have DNA. We also have biomarker extraction, which I'll talk about in a minute, and in midlife in the NCDS and the BCS 70, and again in the early 60s in the NCDS, as well as linked administrative data, which I mentioned earlier. So this slide outlines objective measures relating to anthropometry and other physical functions. However, I've cheated slightly by including self-reported measures of height and weight, which are in brackets. And during the nurse, or in the case of the MCS, trained interviewer visits, measures were taken, and the exact protocols used for each can be found in the relevant user guides. So measures of vision, hearing, laterality, coordination and speech have been measured in the NCDS and BCS 70 in childhood, and hearing again in their 40s, and vision again in the NCDS in their 60s. In midlife, both the NCDS and BCS 70 measure blood pressure, and again in their early 60s in the NCDS. Also in the NCDS, pulse and respiratory function. In the BCS 70 in midlife, and the NCDS early 60s, maximal grip strength, leg raise balance, and timed normal walking in the NCDS in the early 60s. So during the biomedical sweep at age 44 and 45 and 62 to 5, the most recent in the soon-to-be released data in the NCDS, and the age 46 in the BCS 70, blood samples were collected by nurses and biochemical analysis was conducted. And both studies have extracted total and HDL cholesterol, triglycerides, C-reactive protein, glycosylated hemoglobin, and insulin-like growth factors to identify fats, proteins related to inflammation, sugar, and hormones in the blood. In midlife in the NCDS, antibodies, allergens, coagulates, and proteins and diseases related to blood clotting and vitamin D have been extracted, while in the BCS 70 at age 46, protein storage of iron and cytomegalovirus, excuse me if I'm pronouncing that incorrectly, as well as red blood cell count. At age 62.5, which is the new sweep in the NCDS, the bloods will be used to extract a metabolic snapshot of the cohort's biomarkers, such as a range of fatty acid ratios, apolipoproteins, amino acids, sugars, fluid balance, and an inflammation measure, which is very exciting. So now looking at cognitive tests, we have a wide range of measures completed by the cohort members when they were children. We have verbal and non-verbal reasoning tests, verbal and numeracy skills, and tests of visual spatial reasoning and memory. And these can be used as early life predictors, controls, etc. for later outcomes, including cognition. In adulthood, we have literacy and numeracy skill tests, and from midlife, measures of verbal skills in the BCS 70. Also in the new BCS 70 data, we'll have the National Adult Reading Test, which is a method used in clinical settings for estimating pre-morbid intelligence levels. And in the next steps at age 32, and incidentally the MCS, we have and will shortly have, we're measuring the backward digit span, which assesses short-term and working memory. We then have 4 measures in the NCDS and BCS 70 measuring executive function, memory, both immediate and delayed recall, and processing speed. And these have been measured in midlife, age 50 in the NCDS and age 46 in the BCS 70, and have been asked again in the soon-to-be available sweeps of both cohorts. So hopefully, subject to funding, we'll be able to capture these measures over time and increase on our 2 time points. Regarding mental health, there are self-reported doctor diagnosis of depression, anxiety, and mental health. So whether they've seen a specialist, some cases of age of diagnosis, and there are a number of mental health scales used across the cohorts in childhood and adulthood. In childhood, for example, in the NCDS and BCS 70, the Rutter behaviour scales were administered successive times across childhood, and this measures emotional and behavioural difficulties. In adulthood, the primary measure in both the NCDS and BCS 70 was the malaise inventory, which measures psychological distress. And this has been measured 4 times from age 23 to 50 and 5 times from age 26 to 46 in adulthood in the NCDS and BCS 70 respectively. Soon to be another sweep added, as I mentioned, in both cohorts, allowing for both within and across cohort comparisons. The NCDS and BCS 70 and next steps have administered the GHQ-12 in adulthood, and also the SF-36 was measured in midlife in the NCDS and BCS 70, which includes a general mental health measure. And in addition, during the biomedical sweep of the NCDS at age 44 to 55, there's a clinical interview schedule which assesses minor psychiatric disorder in the community. There are also measures of well-being. The Warwick-Edinburgh Mental Wellbeing Scale, that was administered at age 50 in the NCDS, 42 and 46 in the BCS 70, and will also be available in the new sweeps. Also, life satisfaction has been administered a number of times across each cohort. Quality of life scale has been measured 3 times in the NCDS, and loneliness in the recent sweeps of the NCDS, BCS 70 and next steps. So I hope that gives you a flavour of what's available, or some of what's available. Before I hand over to George, I'm just going to give you an overview of a few resources and where to access the data. So most data is available via the UK data service.ac.uk. It's free to download for students, academics, government analysts and the third sector. Each of the studies has a serial number as shown in the bottom right hand corner here, and this will take you straight to the study and the data sets within each study, which are usefully grouped, I think. As we've shown, there's a wide range of data available, and the data goes through a process of classification based on sensitivity and disclosure, and is grouped low, moderately, and the most sensitive and disclosive data. Most data has been classified as low level of sensitivity and disclosure and is licensed under the end user license. So in this scenario, basically your application is authorized directly by the UK data service when you log on, and you can download directly from there. Other data which is under special license is moderately disclosive. So for example, geographical indicators, or sensitive, for example, mortality data, detailed physical and mental health data. And the most sensitive data or disclosive data is available under secure access license. So for example, things like the linked health data that I mentioned. If you want to use this data, you'll need to, you need to build in time for approval and training where necessary if you need that. If you want more information on how to access more sensitive data or specialist data discussed earlier, we would advise visiting the CLS website. So just to say that the CLS website has extensive resources and information on each of the cohorts. Each of the cohorts has an overview of the study of each of the sweeps, sub-studies, documentation, latest research, and is a good place to start. There are also introductions to videos if you prefer that medium. And for each sweep, there are the following resources: user guides for each sweep, technical reports, questionnaires, etc., and user guides for particular data. Particular technical data when you download the data, as well as on the CLS website. And also we have a training and support page on our website where you can find previous webinars on various topics. As I mentioned, introductions to specific enhanced data, subject themes, dealing with missing data, and more. And you can search for upcoming events, and we run a wide range of events throughout the year. Coming up next is genetics and epigenetics data in the British cohort studies. So sign up if you're interested in that for the 6th of March. And this will offer a detailed overview of the data and Q&A. There'll be a webinar on conducting cross-cohort analysis in June if you're interested in cross-generational research, and many more, including using, as I mentioned, polygenic scores in the cohorts, handling missing data, etc., etc. So I'm now going to pass you on to George, who will demonstrate why the British cohorts are such a unique resource in the study of ageing and the types of ageing research that can be done.
Thank you so much, Vanessa, and hi all.
Okay.
I hope you can all hear me. So I will try to share my screen now, hopefully successfully. Okay, hopefully you can see some slides. Vanessa, yes?
That's great, thank you.
Fantastic. Okay, thank you so much. So thank you, Vanessa, and thank you so much, everybody, for being here, for the interest in the CLS cohorts and, of course, the study of aging. Today, as Vanessa, I will mention a couple of things that also overlap a little bit with what Vanessa presented, but I would like to focus on how this unique resource, having data across the lives of various generations, allows us to engage into the cross-generational life course approach to healthy and inclusive aging. And I think this is a unique design that can allow us to do robust science and inform the scientific consensus, but also do very much policy-related relevant research. One of the things I would like to point out, in addition, of course, to the very rich life course data we have across all these different generations, is that these different generations grew up in different historical contexts. So there were a lot of social change, various demographic shifts, macro-social trends, different policies, and so on. And one of the very unique advantages and unique contributions we can make with this design, the cross-generational life course approach, is that where we will be able to understand the impact of social change, macro-social trends, demographic shifts, policies, different policies across generations on population aging, health, and other social and economic outcomes in later life. And I think this is quite important, and of course is unique within this design. Now, you may be thinking, okay, but what are the kinds of questions that we can answer? What are the types of research? And I think Vanessa gave some really great examples, but I wanted to kind of capture some of those, not all of those, in a couple of slides, and then give you some examples of the data and how these data look like, and some examples of this research. Now, from a life course perspective, there are a couple of lots of various important scientifically and from a policy perspective, I believe, questions you can answer. First of all, you can think of the long-term effects of early life circumstances. You may be thinking, okay, George, this is, about aging. Why, bother about early life? Well, early life matters. Early life matters throughout the life course. And I will give you some examples on that later on. Of course, we can think of the impact of intergenerational cycles of poverty and health and how this impacts various outcomes in later life. Very important topic where all the cohorts do really well is about transitions in various areas of our lives, and how these can impact various outcomes in later life. I think a very important area where the cohorts, the cohort data can contribute to aging research is about quality of life functioning and productivity post the onset of chronic illness. Of course, we have data prior to the onset of chronic illness, so we can understand the drivers of chronic illness and so on, but it's equally important, especially for the study of aging and successful healthy aging and so on, to understand what are the drivers of quality of life, functioning and productivity post the onset of chronic illness. And I think this is one area where the cohorts can actually do really well and can contribute quite well. Reversibility and resilience, of course, having available life course data, we can look at the factors that produce reversibility. For example, there may be negative life events or circumstances, disadvantage and so on, at some points earlier on in life or in midlife, and we can investigate, do research on which are the factors that produce reversibility, can reverse the negative impact of all these circumstances or events. Of course, as I mentioned, all of these questions can be viewed through the lens of the changing experiences of different generations, which I think is quite important. And there is another area which sometimes is neglected when people are thinking about birth cohorts and life course data. Having available information over people's lives is a very good resource to understand the impact of external shocks. And quite recently we had a couple of those, the pandemic and the cost of living crisis here in this country and so on. I think understanding the impact, for example, of the pandemic or the cost of living crisis in later life, the birth cohorts will offer a very good resource to actually do this in a robust way, understanding, of course, what has happened to people's lives before these shocks and so on. So there are all these types of questions, but I think these not just questions that inform the scientific consensus, robust science and so on. It's very important, but you may have seen these headlines recently, for example, about the UK state pension that might need to rise to age 71. Currently, it's the current, those that born in 1958, one of our birth cohorts will retire very, very soon this year in 2024, and their state pension age is age 66. The next generation X, it will be age 67 and so on. I think this is very important. It's a very important question for people's lives and, of course, very policy relevant. And I think this cross-generational life course design we have available in the British birth cohorts allow to understand the impact of those different policies on people's lives. And I think this is quite important, and I think it's very, very relevant. And I think it's one of the things where the cross-generational life course approach has a lot to offer. It's not only that, of course, the cost of living crisis, as I discussed, and of course, pension income might need to rise, right, as family costs increase. And of course, this is one of the topics that the cohorts, and specifically the 1958 British birth cohort, which was co-funded by the Department of Work and Pensions for its latest data collection. We have a lot of data, a lot of information about income adequacy in later life and so on. And this is an area where I think also the cohorts can offer a lot for us to understand what is an adequate income for later life and so on. So, and of course, all these are very policy relevant questions. Aside of informing the scientific consensus, which is important, these are all very, very policy relevant. Now, of course, having this data across the life course, and I think Vanessa alluded to this in her presentation, does not only allow us to answer important questions, but also allows us to do, better science, allows us to reduce bias, because science becomes more robust and we have better quality empirical evidence when we are actually able to reduce bias. And there are two particular areas where the data we have across the life course of participants allows us to reduce bias. The first one is causal inference. Of course, the availability of life course data from birth and all this rich information allow for very rich multivariable adjustment. This very rich multivariable adjustment can make the no-muted variables or no residual confounding assumption, which is at the center of causal inference, more plausible. And this is quite important in a way that the richness of the cohorts can lead to better, more robust science when it comes to later life exposures or outcomes. The rich life course data we have can allow us, of course, to look for negative controls or falsification tests. So that can be a very good way to do sensitivity analysis related to causal inference. And of course, potential instrumental variables can also be available depending on the question at hand, based on the rich life course data we have available. So there are ways to make more robust causal inference because of the richness of the life course data we have. And this is quite important. Another area where, of course, we have been doing along with causal inference, a lot of work in CLS, and there's a lot of resources available how to handle missing data due to attrition in the CLS cohorts, is that, of course, having available data before a cohort members attrit, rich life course data allows us to handle missing data appropriately with appropriate methods and restore sample representativeness, which is actually very important. And of course, all this keeping in mind that the birth cohorts have very well-known statistical properties, are representative samples of their target population. So all of these things have gold standards in terms of statistical inference, where we can actually reduce bias either because of missing data, or we can make assumptions related to causal inference much more plausible precisely because of the richness of the data. Okay, so you may be thinking, okay, this is great, a lot of data and so on, but what are some examples of work that has been done related to aging? So some examples, right? There's so much work and so much data, right? And I don't think a whole day or a whole week or maybe a whole month would be needed to present all this great information, this great research that has been done in the cohorts, right? One of the main findings, of course, of the British birth cohorts is that early life matters. Early life matters a lot, and it matters 40, 50, 60 years later, and matters with respect to various social, economic, and health outcomes. For example, early life socioeconomic circumstances have been shown to make an impact much later in various outcomes in later life or midlife. And of course, it's not only just about early life socioeconomic circumstances. Generally, family background and early life does matter. To give you an example of this kind of work, maybe what is a bit less known is about one of the important findings, among others, of course, from the British birth cohort, is that early life mental health has a very strong impact, and I'm using causal language here on purpose, impact on various outcomes in midlife or later on, social, economic, and health outcomes. This is one of the papers that we did recently on the 1958 British birth cohort, looking at health in midlife, utilizing some of the biomarkers we have available, but also mortality data. We found strong associations under assumptions, causal effects with biomarkers, of course, but I want to like to draw your attention a little bit on survival, on mortality. This is the probability of survival. This plot denotes the probability of survival of 4 different groups, denoting 4 different groups with different mental health experiences in childhood and adolescence. So we have 4 groups, one that is stable, the blue line is stable low, the group that did not have any mental health issues, and stable high is the group with the worst mental health problems across childhood and adolescence. What you see there is that those with mental health problems in childhood and adolescence had lower probability of survival. So early life matters quite a lot. So it's not just about various outcomes, including health, economic outcomes, and so on, but also about the length of life, which is quite fundamental. And of course, keep in mind, of course, early life mental health is in itself very much socially patterned as well. So it's one of the important early life characteristics that can also impact on various outcomes in later life, along with socioeconomic circumstances, other family background, and so on. Of course, in the British cohorts, we happen to have data, in this case, mental health, across the life course. And I would like to draw your attention a little bit on mental health in later life, which doesn't get the attention it deserves. Usually, during the pandemic, the pandemic and so on, but also previously, most of the focus on mental health is is in earlier life, which of course it should be, and so on. But there is mental health matters across the life course, across all life stages. And this is some work we did to look for the impact, the potential impact that the pandemic might have had on the mental health, on psychological distress of those over 50 here in the UK. And you see there, there's a very dramatic headline from The Guardian that the pandemic may have triggered a second midlife crisis among over 50s. And well, this is what we find. And this is, long-term trajectories. We happen to have rich data across all adulthood in three generations, three great birth cohort studies. The blue line represents the 1946 British birth cohort, so a study of early baby boomers. The green line trajectory represents psychological distress of those born in 1958, so let's say mid to late baby boomers. And the yellow line represents Generation X, the BCS70 birth cohort born in 1970. What you see there, aside of the generational differences in the levels of psychological distress, you see when the dotted red line kicks in, which denotes when the pandemic happened, you see a spike in psychological distress. And this spike, of course, the level of psychological distress that was reached during the pandemic is higher, equivalent or higher than the previous peak of psychological distress that was observed in midlife. So looking at this, of course, our conclusion was that yes, the pandemic did have an impact on mental health, in this case, psychological distress of those over 50 in later life. And this is quite important because we know mental health, aside of an important outcome in itself, is an important risk factor for various physical health conditions, mortality, and so on. And of course, we were able to do this because we had data across the life on mental health, psychological distress in this case, from three different generations that allows us to make inference about the impact of the pandemic. Of course, it's not just mental health. We have various other information on transitions across life course and so on. I will give a couple of examples on other areas. Housing. This is housing tenure in adulthood on BCS70, on Generation X, those born in 1970. And this is simply the data, no models, nothing. This is simply a descriptive statistic of actually what happens in the data. You see there, some people own outright, most people were owners with a mortgage, but there were renters, other circumstances as well, but people do move around as well. So this is an example of transition or stability and transitions in a very important area of our lives, well, housing. And, this is an example of how this, there is a question there, okay, how housing across the life course and transition changes there, or stability, and what kind of stability, in which circumstances, and so on, may impact various outcomes later on. So these are good examples we believe about in an area which is quite important, and of course, an area which has a lot of cross-generational implications as well, especially thinking of more recently born cohorts, housing, and so on. Moving on, of course, it's not just housing, mental health, and so on. Another area among the many areas that the cohorts have really, really great data, as Vanessa has presented, is employment. And this is simply the working life histories by age 55. We will, of course, have information very soon that will, in this cohort, this information from the 1958 British birth cohort, and soon we will extend these life course histories on working life histories up to age 62 to 65. This is men. The red there denotes full-time employment. You can see blue, some unemployment kicking in, and so on, and everything. But you will see that by age 55, most men were kind of fully employed, and so on. Of course, when we have data across the life course, we can start looking at inequalities, different groups, and so on. So this is men, and this is women. And of course, you can start noticing some stark differences there. So there is more part-time employment, mostly due to family circumstances and family responsibilities, and so on. And this is quite important, right? And of course, you can start looking at this by various other dimensions of inequality, various other groups, and so on. And of course, what happens in our employment, in our life's history, our working lives, does matter for later on, and will matter. And this is another area where the cohorts can contribute quite a lot in understanding various phenomena, various outcomes in later life. Speaking of various outcomes in later life, I will give an example of some very recent research led by Vanessa, as it happens, on where we looked at economic inactivity just before the pandemic. So in the 1958 cohort, just before the pandemic, and during the first year of the pandemic, we looked at economic activity and inactivity. And we did this because you may have heard of the Great Resignation, which is it's a phenomenon where more people than usual resign. And of course, it's something that specifically in the UK is thought of to be concentrated mostly in midlife or early old age and so on. So we looked at this, and of course, as you have seen, we have data across the life course on people's working histories. And of course, at age 55, we knew that 76% of this cohort were employed in full-time employment. So the question is, what happened 7 years later at age 62, just before the pandemic started? What happened is that there was a huge drop. 51% of those people were fully employed. And maybe you might say, okay, fine, that's before the pandemic. What happened during the pandemic? Yes, the trend continued, but what we can see, I think, from this trend is that this phenomenon, that this reduction in economic activity and employment is not something that was triggered by the pandemic. It's something that was driven by factors much before the pandemic. During the pandemic, this trend was continued or perhaps accelerated maybe a little bit, but actually this is something that happened before the pandemic. What the cohorts can contribute to this is to have all these important life course data, so we can answer a very important question. What are the important drivers of this drop in economic activity? So we did this, Vanessa did this, and this work will be available very, very soon. But to give you just a flavor of what we can find out based on the rich data we have from these cohorts on people's lives. So in this case, what drove this reduction in economic activity? What drove this reduction from 76 to almost 45%? First of all, we know that cohort members from advantaged socioeconomic backgrounds in childhood that went on, for example, to own their houses outright or went on to have private pensions or had relatively higher income, they choose to retire. So this is partly driven by a lifetime of socioeconomic advantage. And of course, recall that these are the people that are most likely are expected to live longer, generally, and on average, healthy. However, it's not just this. Long-term illness was also a factor, mostly in men. So long-term illness was one of the key factors that, along with socioeconomic advantage throughout the life course, that drove economic inactivity in men. Speaking of health and long-term illness, one of the other areas where the cohorts can offer quite a lot, and I think one of the very recent trends that we have been observing in the cohorts is the generational health drift. So this is an infographic that we try to summarize a lot of work that has happened in the previous birth cohorts, comparing the health of various generations, which is something that the design of the cohorts allow, comparing the health of various generations at specific ages. So what we have been finding is that despite the fact that younger generations are still expected to live longer, despite the stagnation of life expectancy in the UK since 2010, and despite the pandemic, the projections of ONS project that younger generations will live longer. Despite this, they have worse health outcomes, including diabetes, obesity, poor self-reported health, multimorbidity, and mental health. And of course, this can have various implications for population aging, right? For the healthcare system, of course, for the labor market and so on, because if younger generations are less healthy at specific ages and they're expected to live longer, then that means they will spend more years in poor health. And of course, that has huge implications. And of course, if you think about employment, the economic inactivity, and the previous finding has huge implications, as I said, for the labor market, and of course, for the healthcare system, and so on. And this is something that uniquely the cohorts offer this, can allow us to investigate this very important trend, understand its drivers, its antecedents and consequences, and so on. I will finish my very brief presentation by focusing a little bit on inequality. I mean, we have alluded a little bit about inequalities, but of course, inequalities, health, and other inequalities, in this case, I'm giving some examples of health inequalities, are very much present as we speak in the older population, obviously. And of course, we should do something about it and reduce health inequalities, of course, eliminate if possible health inequalities. There's a very strong moral case there. Fine, there is that, but obviously, whatever we observe now, inequalities or whatever we observe now in later life, does not appear magically. There are lifelong processes that lead to inequality appearing later on. And to give you an example, this is net family income across a working life in one of our cohorts, was born in 1958. This is the median, and then you see the 90th centile and the 10th centile. And you will see there that how inequality expands across the life course. And this is quite important because I think generally speaking, aiming for healthy longevity in the 21st century and so on, reducing or eliminating health inequalities is one of the necessary conditions. And to understand health inequalities, do robust science, and of course inform policy, it's very important that we understand the lifelong processes that led to what we observe now in later life. And this is one example with income, but of course there are other factors that might lead to inequalities and so on in later life. So I will finish my presentation by saying that I know that today we kind of focused mostly on long-standing studies that began in 1946, 1958, 1970, and so on. But this is a new era for the British birth cohorts. This is the first time we have 3 generations above 50, the age 50. This is a new start for us, not us at CLS, but also I believe for science generally, because this unique design of the life course approach across various generations can now start contributing to the study of population aging. And of course, population aging is one of the very dominant trends of the 21st century. As Vanessa suggested, these data are freely available, so please download them and use them. And I look forward to the fantastic research that you will be doing with this great research. So that's it from me. Thank you so much, and happy to answer questions during the Q&A. Thank you.